In 3.2, it is just a continuation of 3.1. So we're going to be using 3.1 properties, which are reciprocals, quotients, and Pythagorean properties. Only we're going to apply them to more challenging problems. So when you look at example 1, you can start on either side of the equal sign, but you want to choose the side that looks more complicated. So on the left, it looks like there's more to do than on the right. So on the left, you're going to FOIL 1 times 1, 1 times negative cosine, positive cosine times 1, and positive cosine times negative cosine. And you get this, so that would be the first step. So if you have two parentheses, go ahead and FOIL them together, then see what happens. The cosines cancel, so we have 1 minus cosine squared. And then you want to look at your Pythagorean properties. If I were to subtract cosine to the other side, I would have 1 minus cosine squared, which is sine squared. So this becomes sine squared, which is what we wanted to prove. So the first thing I did was I FOILed, then I simplified by canceling the cosines. That's not simplify, simplify. And then we use Pythagorean properties to plug in sine squared. In example 2, we have cotangent plus tangent. And even though we have properties for cotangent and tangent that have cosecants and secants in them, they're not as useful as the sines and cosines ones. So we're going to change these into sines and cosines. Whenever you have two things being added together and at the end there's only one thing, you probably are going to get fractions and get common denominators with those fractions, so you can combine them into one term. So cotangent, we're going to change into its quotient property, cosine over sine. Tangent, we're going to change into its quotient property, sine over cosine. And like I just said, we're going to get common denominators and try to combine these fractions together. So if I give this a sine on both sides, and I give this fraction a cosine, then that is going to change these fractions into cosine squared over cosine sine plus sine squared over cosine sine. Now don't cancel anything because you're just going to move backwards. You want to keep moving forwards. As soon as you get common denominators, add or subtract your fractions together. So in this case we're adding cosine squared plus sine squared over common denominator, cosine sine. Then the top is Pythagorean. If you look at your Pythagorean properties, it's the first one. Cosine squared plus sine squared is 1. So the top is 1. And then we can get to the end now, but you probably want to show why we get to the end. You can split this into 1 over cosine times 1 over sine. And 1 over cosine is secant. And 1 over sine is cosecant. The order doesn't matter. It's backwards from what we want, but it's the same answer. So that's example 2. In example 3, we have sine over 1 plus cosine, and at the end we have 1 minus cosine, which is the conjugate. So we're going to multiply both sides by, or top and bottom by the conjugate, which means you take the part of the fraction that has two pieces, and you just change the sign in the middle. So instead of plus, you change it to minus. Now we do on top and on bottom to keep the fraction balanced. Now what I'm going to do is leave sine alone on top and don't distribute onto the 1 minus cosine because I want to keep it for the end. And on the bottom, I'm going to go ahead and FOIL. So 1 times 1 is 1. 1 times negative cosine is negative cosine. Cosine times 1 is positive cosine, and cosine times negative cosine is negative cosine squared. So I've got sine, 1 minus cosine, and on the bottom, those cosines cancel. I get 1 minus cosine squared, and then the denominator will change into sine squared. Why does the bottom change into sine squared? Because it is Pythagorean. If you go back to the same one that we keep using, if I subtract cosine squared to the other side, I get 1 minus cosine squared, which ends up giving you sine squared. Now we can see that one of these signs will cancel, so it's not going to be squared anymore, and you get what you wanted to prove. You get 1 minus cosine over sine. So reasons are, you started with a given, we multiplied by the conjugate, then we FOILed, then we canceled cosine, or we simplified, then we used our Pythagorean property to take out the cosine and put a sine squared in, and then we canceled sine. In example 4, we want to figure out how to get to cosecant. So what I'm going to do is same thing that we did in example 3. Example 2, get things into sines and cosines. So that's going to stay, that's going to stay. Change this into 1 over sine, which just is going to put sine in the bottom of your cosine squared. Now, I want to get a common denominator so that I can combine these two terms and eventually only have one term. So put sine on the bottom and sine on top, which is going to make that squared. So I got common denominators, and now I have added them together. And now on top, you should see your Pythagorean property again that we keep seeing. We get 1. And 1 over sine is reciprocal. 1 over sine becomes cosecant. So you can go ahead and change that into cosecant. That's what we wanted to prove. So we started with a given. We first did reciprocal property. We got common denominators. And then we used Pythagorean property to get the 1. And then we did reciprocal properties again. So this seems weird that we would get rid of the cosecant that we need, but we got rid of it so that it was compatible with everything, and then we brought it back at the very end. So sometimes you have to get rid of something just to bring it right back.